Hi. Now in today's session we learn to solve system of linear equation using matrix method. So first consider any equation having a1x plus b1y equals to c1, and in this system consider another equation a2x plus b2y equals to c2. Now, how we are solving? In previous classes, we already have studied based on a1 by a2, b1 by b2, and c1 by c2. We can decide whether it has one solution, many solution, or no solution. If the ratio a1 is to a2 not equals to b1 is to b2, this is one condition. a1 is to a2 equals to b1 is to b2 equals to c1 is to c2. And the third condition is if this ratio equals to second one and not equals to the third. In this we have one solution. In this condition, many solutions, infinitely many solutions. So infinite solutions. Here no solution, that is 0. These two conditions having solution means we will have the value for x and y. So these two are both consistent. Means in these two conditions, this system is consistent because have the solution, and here this is inconsistent. So if a system of equations have solutions, then it is consistent. If don't have solution, then inconsistent. Now using matrix method, how we will solve? Just look here. As in our first, how we are finding or the product of two different matrices. Based on that, first try to consider A as a matrix with coefficients only. What are the coefficients? A1, next B1, A2, B2. Four variables. X equals to, how many variables we have in the system? Two variables, x and y. So for variables x, y. And what is the resulting of both the equations? With the constant. Constant is C1 and C2. C1, C2. So this equation can be written as A into X equal to B in the form of matrix. Here the equation can be as A x equal to B. A x, where A is A1, B1, A2, B2, and X is X, Y. B is the resulting value of C1 and C2. Just look on and think of the product of the matrix. What about the first? A1x plus B1y. The rule of multiplication for the matrix equals to C1, the first. Then A2x plus B2y equals to C2. So the system can be written as Ax equal to b. After this, to find the solution, we have two different cases. Case 1, as the system is ax equal to b. Now to find the variable, just separate x one side. So to separate, multiply with a inverse. A inverse ax equals to a inverse b. Multiplying both sides with a inverse. Now as here a inverse into a into x equals to a inverse into b. A inverse into a will be identity matrix. As in the numbers 1 by 2 into 2 equals to 1. So this is 1 by a. Inverse of the matrix A. 1 by a into a will be identity as 1. Ix equals to a inverse b. So identity into x will be x only. X equals to a inverse b. Now you have to look for this condition, x equal to a inverse into b. That means to find the value of x, first you have to find the value for inverse of a. And what is the condition? In which condition we can find a inverse? If it is non-singular matrix. That means determinant of matrix A should not equal with 0. It is only possible if matrix A is non-singular. So in first case, if determinant of A not equal to 0, then only we can find. So x equals to A inverse B is the first condition where determinant of A not equals to 0. In this condition, we have only one solution because inverse is unique. For any matrix, inverse is unique. Hence, we have only one solution. And this is the case for A1 by A2 not equals to B1 by B2. Now come to the next condition where determinant of A equals to 0. Second case, if determinant of A equals to 0. This is when determinant A not equals to 0. Here we can write if determinant A not equals to 0. So we multiply it with A inverse. Now if determinant A equals to 0, then how can we find the solution? Now it is based on adjoint of A. In this case, you have to calculate adjoint A. Now calculate adjoint A into B and then look for this condition, what you are getting. Adjoint A into B, if it is 0 and if it is not equal to 0, again we will have two different conditions. If it is not equal to 0, here 0 stands for 0 matrix. 0 matrix, null matrix, because this is the product of two matrix. Product of matrix. So 0 matrix. And this 0 is only 0, determinant of A, only a number, while this is zero matrix means 0 0 0 0, that type. If it is not equal to 0, then that system don't have any solutions. Then solution does not exist. Does not exist means it is similar with that condition, a1 by a2 equals to b1 by b2 not equals to c1 by c2. This is in matrix method. Again, if it is 0, zero matrix, then it can be consistent or inconsistent based on number of solutions. In this condition, the system has either many solutions or solution does not exist. Both conditions are applicable in this one. If determinant A equals to 0 and adjoint A into B equals to 0, then system has many solutions, or both conditions are here, or solution does not exist. So only in this condition we cannot identify whether it is consistent or inconsistent. But here, if determinant A equal to not equal to 0, then we have unique solution, consistent. Here, if determinant A equal to 0 and adjoint A into B not equal to 0, zero solutions, no solution. In this condition, it is inconsistent. But if determinant A equal to 0 and adjoint A into B also equal to 0, in this condition it can be consistent or it can be inconsistent also based on number of solutions, either many solution or zero solution. Okay, let's try with some example so that we learn how we are solving for x and y. Let's have examples. First, we'll try with 2 into 2 only, means having two variables. 2x plus 5y. You can select any equation upon based on your choice. Equal to 1. Second equation, 3x plus 2y equals to 7. So to find this, first we have to check whether it is singular or non-singular. Here, look this. A equals to the matrix with coefficients only. 2, 5, 3, 2. X is the matrix with variables x, y, and B is the matrix with the resulting constant only 1, 7. 2, 5, 3, 2. A is 2, 5, 3, 2. X is with the variables x and y, and B is the resulting matrix. Now check whether singular or non-singular. Determinant of A. 2, 5, 3, 2. Cross multiple. 2 to the 4 minus 15 minus 11 not equals to 0. Here determinant A not equals to 0. So the system has unique solution, means we will have the value of x and y, only one solution will be there. Now this can be find out with help of x equals to a inverse b. So what is our solution? X equals to a inverse b. So first find a inverse with help of the matrix. So to find a inverse we need cofactors. 4 elements, find all 4 cofactors. First cofactor, this is 1 plus 1 is even number, so plus, and then delete first row and first column. First row and first column, so 2. This is 2. Now second, a, first row, second column, a 1 2, 1 1, then 1 2, 1 2. Delete first row and second column, 3. And look here, this is 1 plus 2 is odd, so minus 3. Then for second row, first column, again here 2 plus 1 is odd, so minus 2 1 5, minus 5. And the last 2 2 is 2. So directly here I am writing A inverse. A inverse equals to, we have the formula 1 by determinant of A into adjoint of A. Determinant A value is minus 11 and adjoint A 2 minus 3 minus 5 2 transpose. Now to find x equals to A inverse B. A inverse is 1 by minus 11 and transpose this 2 minus 3 minus 5 2 into B, the value of B 1 7. 1 by minus 11, and here x is what? X y. Now find the product using the product rule. First element with the first, 2 into 1 plus minus 5 into 7. 2 1 is 2 minus 35. Then with the second row, minus 3 plus 14. So this is equals to 1 by minus 11 minus 33 and it is 11. So the first value x equals to minus 33 by minus 11. So x equals to minus 33 by minus 11, which is 3, and y equals to second element 11 by minus 11, minus 1. So these two are values for x and y. X is 3 and y is minus 1. So in this way we are finding the solution for any system of linear equation. First we need to find determinant of A and decide whether singular or non-singular. If it is not equal to 0, then find the solution. If it is equal to 0, then we cannot find the solution for system of linear equation. Because in that condition either we have many solutions or 0 solutions. But you can write after finding determinant A, if it is 0, then adjoint A into B we need to find out. If it is also 0, then has many solution or no solution. If that is not equal to 0, no solution. So you try with many examples. This much only for today. Thank you.